I tell you what, every day I am amazed. Well, first of all, my stupidity. I screwed up our very first problem of the summer. Oh well. But I'm also amazed at just the power of this little computer that I have. I mean, the size that it is, and what is it? I mean, because look what's going on. I'm uploading a file on YouTube that track 6 of this lecture. I've got this Wiley Plus thing open. I'm filming myself all on one device. I mean, it's just amazing to me. I mean, my Packard Bell 386 that I bought back in 2002 on Okinawa would it wouldn't even play this Roger Rabbit game. 85 kilobytes of cache memory, 256 kilobytes of cache memory, and 85 megabytes of full storage. Shoot, you can't even send a text with that much without, yeah. Oh my goodness. Anyway, all right, 4 identical spheres have charges. Well, let's just draw this out and then look at what we've got here. So I've got 4 identical spheres. Well, maybe I should have stuck with that a little bit longer. I'm going to draw them. So I've got one of -8 microcoulombs. Get used to that microcoulomb thing, please. Okay. And then I've got, this is A. And then I've got charge B has -2 microcoulombs. Charge C has +5 microcoulombs. Micro is 10 to the -6, and charge and D has +12 microcoulombs. All right, so let's take a look at this. 2 spheres are brought together so they touch and then they're separated. Which spheres are they if the final charge is +5 microcoulombs? Okay, well, let's see. If I bring A with this, that'd be -5 because I get -10 charges. Be my total divided by the number of spheres would be 2, so that'd be -5. 2, and this one would be 1.5 each because that'd be +3. What about 12 and let's see, 12 and this one give me 17. That doesn't quite work. What about 12 and -2? That gives me a total charge of +10 microcoulombs divided by 2. Oh, there we go. It'd be B and C. So what do our answers look like? So it'd be B and D, I bet. In a similar manner, which 3 spheres are brought together if the final charge is going to be +3? So you see how this works, right? So I've got to get something where I add them all up and divide by 3, and I wind up with 3. So if I do 17, oh, I see what it is. Because look, I got 12 plus 5 is 17, minus 8 is 9, divided by 3 give me +3. See how that works? So I'd have to bring together A, C, and D. That one would work. All right, then I'll let you all figure out the last one. All right, so what's problem 8 look like? This is fun. Yeah, I want to move on. I'm not getting a grade. I don't care. All right, in a vacuum, 2 particles have charge Q1 and Q2, where Q2 is 2.8 microcoulombs. All right, that's the micro. They are separated by a distance 3.3, and a particle 1 experiences an attractive force of 2.9 newtons. All right, so now we're out of the charging thing, and now we're into what is known as Coulomb's law. All right, Coulomb's law is huge. Here's Coulomb's law in a nutshell. That's not Coulomb's law at all. Oh, here I was getting ready to do these, but we kind of did them orally there. But here's Coulomb's law. First of all, I'm going to do Newton's gravitational law. Okay, Newton said this. Gravitational law. Here it is. F is equal to that big G. Remember that? M1, M2 divided by the distance of the centers of mass of those 2 massive bodies squared. That's Newton. Let's look at Coulomb. This is also a force. Coulomb's law If you go to physics camp instead of church camp, you sing Coulomb's Law instead of Kumbaya. Sorry, bad joke, but I always have to crack that the first day of class and you're not here. All right, so anyway, Coulomb's Law looks like this. The force, and we look at the absolute value of the force, just like we looked at the absolute value of the force here, and then we draw our pictures to figure out the direction that it goes, is equal to an electric constant K, where K is equal to 9.0 times 10 to the 9th Coulomb, or newtons meters squared per Coulomb squared. That's K. That's called the electric constant. All right, and this electric constant, and then we take the absolute values of Q1 times Q2 divided by R squared. Now that's the way we do it in Physics 220. In Physics 250, you would do the 3x3 matrix of multiplying those together, and who cares? Because it's a radial thing, right? But we can draw the picture, right? So let's look at the slides. What do the slides say about this? Let's quit that one. Where's my other PowerPoint slide? Didn't I have the other one loaded? Am I going to waste your time some more? Am I wasting your time some more? I am. I apologize. All right. So, well, that's a good place to stop on that one anyway.